Alô, alô? Uh, Hello, everyone. And let me please know in the chat that you can see me, but you can hear me well. So if there's no issues with the microphone like the last time. Yeah, long time no see you. I recently upgraded my Wi-Fi router, so it may work much better now than the last time. Okay, okay. Oh, okay, so if someone is joined, please let me know if you can see me and hear me well. And we will start roughly in 1 to 3 minutes, something like this. And today's lecture will be about mostly about the DynamoDB, but also we will touch all over databases, which is available from the AWS site. Okay, so there's already pluses. So let's wait 1 more minute and let's get started. And also, if you have any questions regarding the module 4, about the task, or about the information about the resources we would use, don't hesitate, ask them in the chat, so I'll try to answer all your questions. Actually, I would say with the comparison from the third module, this one would be much easier, but but then on the same way, it would be much more interesting because now we are touching the databases, such a crucial part about almost every solution, every application. So yeah, you should understand and you should know how it works, what's the downsides of using these database, different database types, and what you should use and how should you maintain it. Okay, so let's get started. We still have not much informative slides. So this one is about who we are and what we're doing. My name is still Anton Kostikov, so you're welcome to ask me anything in the chat, or let's stay connected in the LinkedIn. Unfortunately, I missed the link. So there is the course modules, and now we are on the 4th one. So at the end of this weekend we should have the task 4 completed, and it would be checked by your classmates who did almost the same. And this module is called Integration with NoSQL Database. Today we'll touch such topics about the AWS databases types and what are the advantages and what are the downsides of one or another database. And we will a bit deeply talk about what DynamoDB is, how it can help us, and again we will talk about the advantages and disadvantages of this database. We'll briefly touch the data structure in the DynamoDB, and then we would have, I think, 20, 25, 30 minutes to talk about the hands-on task from this module. Okay, so usually when you're thinking about running your application, the first thing coming in mind is, surely the first one is what the application is and what it would do. But the second part is where to store your data. Actually, you still have an opportunity to store all of your data inside the TXT files or something like this. Okay, so just say it like a text and that's it. But in case you are going to any load from your customers, you would feel but just reading the file and trying to get something from this file is quite hard and very resource dependent. So whenever you're trying to open this file, try to find something in this file, it would take so many time, and it would rely on your very hard on your RAM or on your CPU and so on. So this is why I'd say quite clever people created the databases. Databases is a thing where we can store data, and this data would be much more easier accessible for you, for your application, and it provides quite more, it works much faster than just opening and closing the files. So, okay, so now we have database. One of the most simple option is just to run this database on your machine. So you have a server, let it be hardware one, or it's just a virtual machine inside any cloud provider. And actually you can just download the MySQL, for example, or PostgreSQL, and just install it on your virtual machine, create the tables and so on, and that's it. So anytime your application needs something from this database, it would connect to the via the IP address or URL, so something like this. But now, to maintain this database, you should also think about the security of your machine, because even the database itself, in a database itself, maybe found some vulnerabilities which may be used by some hackers or something like this. So you always should look for your security. And this is why AWS decided to provide the databases as a service. What does it mean? Actually, it's similar as we've been talked about the S3 bucket and Lambda functions, so we just don't need to provision any infrastructure which underlies in our database. What does it mean for us? So we are just saying, okay, AWS, please create for me the database. And that's it. So now we just have the entry point for this database. Usually it would be the URL, which we can ask, okay, which when we will try to ask something about the data inside the database, it would tell us, okay, yeah, here we go. There's your information. We would connect to this database, run all this SQL or just any requests, and we would get the information back. And the best part about these managed databases is that we don't need to care about the security at all. It would touch us actually whenever AWS itself would run any security patches, but it's not in our duty anymore. So we just only need to think about, okay, AWS said we should run we would run security patches. Where will be the downtime? But at this point, we may say, okay, I still have some replicas of my database, so go ahead, AWS. I would just redirect all the requests from my application to another database, which is quite similar with the master one, let's say. And now let's talk a bit about the types of database in AWS. So first one is RDS, so relational databases. I think it's the most known type of databases. So it's the one where we are running SQL queries to get any data. The best point about RDS, relational databases, is that we have relations between tables. So for example, one of your table may relate with some table line alongside with this one by, for example, ID. So for any keys we may imagine, we are just building these relations, and whenever we want to find the information about something, it's quite easy for us because we just say, okay, take this ID, for example, and get me all the data, all the information, and don't forget to add the information from this table, which is which have some relations with this table by this key. It's quite a good option. And from AWS point perspective, we are asking us just to say which size of the virtual machine we would use for this particular database. So we are saying, okay, we need something in the middle, so let it be 4 CPU and 32 gigabytes of RAM, but that would be enough for us. And the storage for these databases would be provisioned for us and would scale from our needs. Also, from the AWS side, they are providing us quite convenient ways to replicate in our databases and replicate not inside one AZ, but for different regions. It makes it quite easy to scale in our application from one region, for example, to another. So if we have customers from around the world. The second database is Aurora. Actually, it's also the relational database, which built upon MySQL or PostgreSQL engine. And for us, Aurora is already built and stores the data for multiple AZs. So it's highly available. So whenever something happens with, for example, server or something like this, in our RDS or maybe EC2 instance may lie, Aurora would take care for it. And whenever it happened, it would provide us with the data we had. So the next one is Elastic Cache. Actually, it's just the key value in memory database. It's built upon Redis database. And the advantage of this one is what it stores all the data in the random access memory, so in RAM. So that means that this data would be accessible much faster than the one which is located in the typical SSD or HDD. We can use it maybe for any kind of activities which relies on the which changes so often. So, for example, if you want to count the users who's logged into your web page, it's not a bad idea to store the credentials or cookies from this user to the Elastic Cache. So you always would have the access for this data, and this data would be quite fast available. And the same way you may delete the data from Elastic Cache. So the next one is DynamoDB. And the best point about DynamoDB, actually it's a proprietary database which built by AWS themselves. It's just a NoSQL database, let's say maybe key value storage, where we can store all the necessary data. And actually we would take a look at it a bit later, and we would see how the data looks inside it. And the best advantage about this one is, once again, whenever we are deploying in our table in the DynamoDB, this table is very highly available because all the storage in our tables is stored on different nodes at the AZ. So once again, whatever happened with the server, and our data would be safe because it's replicated among different nodes. Next one is DocumentDB. Actually, I've never worked with one from the bottom side. So the only thing I may say is the DocumentDB used whenever you need to store any kind of documents, surprisingly, in the database. What does it mean? So imagine you have kind of big topics about your patients in your hospital. And it's not a bad idea to store this kind of data inside the DynamoDB because it was built to have such a big values under the keys on this database. Next database is Neptune. Usually it's used for any application which drastically relies on the connections between data. So you can think about it like maybe social network. So whenever someone sent a like or made a friend with someone else, so all of these relations may be quite easily and conveniently stored in the Nipton database. I can't say much about QLDB, but only what it stands for, Quantum Ledger Database. It used usually for to store the financial transactions. And the point of this database is that none of this data may be removed. So, and all the time someone is added or removed, you will be provided with a cache, so you would know that something is missing, but it's quite hard just to remove something without any, not notifications, but without being not noticed. Let's say it like this. So if you have something, if you want to do something about these transactions, you won't be able to do it anonymously. And the last one from this series, but actually maybe I mentioned not all the databases from AWS, but still, the last one is time series database. Usually it's used for IoT, because all the IoT sensors relies on the time when something is happened. So, but actually you can store all the time series data right inside your RDS, for example, or even NoSQL databases, so like DynamoDB, which stores just Q value. But the time series databases provides us with the more optimal way to do it. So let's say you have a timestamp and you have kind of data, which we fetch right in this time. So whenever you need to build something around the data, which relies on time so hard, so I think you should use the time series databases, managed time series databases from the AWS. Okay, and now let's talk a bit deeper about the DynamoDB. So, as I said, it's a highly available database provided, managed highly available database, which is provided by AWS, and it's no SQL. What does it mean? So, it don't have any, it don't build any relations between tables. So you just have in our case, from the perspective of another task, we just have the partition key, which should be unique. Okay, let's say primary key, which should be unique for all of your table. And under this primary key, we will mark the items. So once again, from the perspective of this fixed task, it would be ID of a product. And under each ID would be the item would be located. So item is quite the strings inside in our table. And all of these items may have almost unlimited amount of attributes. So you don't need to say, so, okay, my table should have this, and these attributes. You can just say, okay, I want to add this kind of ID and with this amount of attributes. Let it be name, price, count, or something like this. It doesn't matter. And the best thing about it, so whenever your application, let's say, would grow and you would like to implement some additional functionality, you don't need to think about the relations between your tables. You can just add one more or whichever you want attributes and just use them. So whenever your item would not get this attribute, it would just give you null, as I remember, but actually we may try to check it today once again. And the idea behind the primary key, So it should be unique among your table. And in this case, in case of DynamoDB, we can see what the primary key actually consists from partition key, which we must specify whenever we create in our table, and the sort key. And in this example, okay, it's just some kind of ID and type. But actually, maybe a bit better example, maybe something like you may use, for example, user ID, and this user may be the customer of one cafe and the another cafe. It would be the same user, but we would like to separate these two users. So we would see that the partition key is the same, but the sort key, for example, the ID of the cafe, which he's usually meeting, would be different. So in this case, primary key would consist of the user ID and the ID of the cafe he's usually visiting. Okay, let's move on. But I think, yeah, once again, about the pricing. It's not a bad idea, once again, to take a look at what does it cost for you. But as I remember, you'd have quite big free tier quota. But anyway, I would just try to send you this link so you may take a look for what and how you would pay in case you're using DynamoDB. Okay, here we go. Just send it. Let me close this one. Okay. So I suggest now we would take a look at this week's task. Let me take a look. Okay. Yeah. So if you remember, at the previous week, we've been talking about the API gateway and Lambda functions. We've populated the Lambda functions with mock data, and we tried to call the API gateway specific URLs and fetch the mocked data. So, and this week we would try to make these Lambda functions not use this mock data, but talk to our DynamoDB. So as I remember, the first point of this task would be about creating the database. Actually, it's as easy as you just should go to the AWS console. Okay, let me maybe share the screen. Okay, this one. Okay, forgot to log in. Oh, okay, please bear with me. Just a second. Okay, here we go. What's it about user? Just download in DemoFray. Now I will try to show you how to create this table if you still not succeed, and you would see how easy it is. Okay, yeah, I missed this one, not this one. Okay, here we go. 1, 2, yeah, here we go. So to create a table, we just need to go to the DynamoDB, and whenever we are here, we just need to say, okay, create table. What do we need? We just need to specify the name of this table. So let it be new table, and we also should specify the partition key, which should be unique for all of your table. There is also the data types which DynamoDB supports. It's number, binary, and strings. And under the strings, as I remember, the DynamoDB should understand the sets, hash tables, and also lists. Now we just need to create the table with the default settings. It says that it would be provisioned capacity from this side of DynamoDB. So actually what we will be paying for, we would pay for for the capacity which been provisioned for us. Here we have a read capacity unit and write capacity unit. Actually, you may change it for your needs. And somewhere in here, okay, maybe I will try to find it and send it to the chat later. So there is somewhere a calculator. So how to calculate the amount of RCU and VCU you need. And now we're just clicking create table. And here we go. So we already have the table. Each line is actually alongside with my already created tables, which I created to complete the task. And actually that's it. So now to store the data inside any of these, it's as easy as go in here and create the item. So as you can see, let me maybe open it in the new window so you can see the difference. So as you can see, this one is already consists of kind of tables, kind of columns. Its ID, which is primary key from my table, description, price, and title. But now, whenever I'm trying to create the item, it says, okay, provide me with the ID and nothing else. And this is what this is how the NoSQL databases work. So you just it's not necessary to specify all the columns you are using. So it's enough just to say that okay, so this new ID, and we also may add some attributes like string. Let it be price. Okay, maybe string is not the best idea. Okay, let's be not the price, but description. Let's say description. Okay, and actually here we go. We just created the one more item, which consists just from the ID and from the description. And whenever I try to run any other attributes for my item, it would actually let me do that, and let's say the new column with new attribute would be created for my table. I may use it or may not, so it's my choice. But actually what I'm trying to say is you don't need to provision or create something with your table. So you just specify the primary key and that's it. Now feel free to fill your database with all the attributes and all the data you want and need. Okay, once we've created the database, let's take a look what should we do next. We should create one more, not the database, but table. We created one, we created a second one, which would consist from the product ID and count. Actually, that's it. And unfortunately, I didn't have the time to talk to Dazik, but Dazik said that it's not the best choice to create two tables for such kind of architecture. So maybe sometime later he would tell us how to build this table, how to build table for this application in more proper way. But now still, we just created the tables. Now we should run, create and run the script, which would fill the data. If you're using Python, I would suggest you to use Faker library, which is just generates the strings, numbers, etc. So whatever you want for your kind of data, and then you would just fill in your database with this random data. Next one, task 4.2. Now we should just extend our already created AWS CDK stack with the data about in our database. So actually, what does it mean? So right now we have two Lambda functions from the previous week, and both of these Lambda functions just been getting the mock data and giving this mock data to us. That's it. So now we should say to these Lambda functions, okay, guys, here we go. Now there is no mock data. Now to give me something, you should go to the database, take this data, and then give it to me in the proper formation. So for another case, it would be JSON. And what should we do? What should we do? We just should implement the functionality of connecting to the database for 2 of these Lambda functions. And now, what should it do? Actually, so from my end, in case of product list, my Lambda function, first of all, would instantiate the connection to the database. It would fetch the database names from the environment variables, which I provide from my main stack creation. Now it would try to get from this object the table itself. And what it would do next, it would just try to get all the items from these databases. So now I would work with the hash tables, which is populated with the data from my database. And whenever it's done, I'm just trying to process this data and say, okay, here we go. Now we just don't need all of this data. For example, if we have any additional attributes, now you should just take something that I need and generate the JSON, which would be populated with necessary keys and values from the perspective of our application, from the front end side. Actually, we don't need to make any changes to our front end. This is why actually I didn't open it. But in case you changed your API gateway, okay, you should just go and change your API gateway URL. That's it. And actually, that's it. So what my Lambda function doing now? So we just go into the DynamoDB, taking all the data, formatting all this data, and sending this data back to me, or for example, back to the front end part of the application. And there is also, as you may see, there are some exceptions, and which is kind of the additional part of this task. But actually, that's it. We also should create the Lambda function which serves to get the exact product from the database with the same way. So it should not take the mock data, it should go to the database and ask, okay, so do you have the item with this particular ID? And the database should say, okay, yes, I have. Now here we go, here it is. Or say, no, I don't have such an item, so you should just handle this kind of error somehow and log this. So to not be just to make troubleshooting a bit easier. Okay, there is a remark about as a result of being model. So as I said, we don't need to make something at the front end part. So it's just the example of how the data from the Lambda function should look like. Because since we are talking with 2 tables from our DynamoDB, we should concatenate this data by using this primary key. In this case, it's ID. So we are saying, okay, where is the ID? Here is the title, description, price, and now we are trying to add the count of this particular item in our shop. Okay, now we are integrating it, and then here we go. And in the task form, what is expected? Right now, we've been working only with the Lambda functions, which creating the which processing the GET requests. But in this case, we should create one which handles the PUT request. So what does it mean? It would not try to fetch any data from the database. It would try to put something inside it. So what does it mean? So we will say to this Lambda function, okay, Lambda function, where is the data I want you to put inside my DynamoDB, inside this particular table? or tables in our case, yeah, because we already have the table for products and they want to count all these products. And this lambda function would take all of this data from us, would try to make sure that this data is in the proper shape, let's say. So we have all the necessary keys, all the necessary values, and the values have the necessary types. And it would just take this data, validate it, and put inside the DynamoDB table. But if you would see at the additional tasks, the last one, we should use it in the transaction-based manner. Actually, what does it mean? So as I said, we already have two tables, one for just products and another one to count all of them. And in case, let's imagine you're saying to this lambda function, okay, just put it in here and in here. It's not doing it simultaneously. It's doing it just one by one. So for example, it would put it inside the products table and then inside the count table. But what would happen if for some reason the second request to the count table would fail? So in this case, we would create the item inside in our product table, but we would not have this data, all the necessary data for the count table. And for us, what does it mean? So whenever some customer would try to use on our web application, some kind of error may happen, because lambda function, whenever it would try to fetch all the data from both of these tables, would not find any information about the amount of the products inside in our warehouse, let's say. And that's why we should use the transaction-based approach. Actually, what would happen in this case? We would say, okay, lambda function, just put this data to this and this table. And in case this lambda function would fail on any of these steps, it would just not happen. So actually, if it successfully put something inside the products, but failed to put it in the count, it would just remove it from the products. So there is no option for lambda function to store something just in one database, but not to another, even for any kind of reasons. So, would it be network outage, or maybe just the data is not validated properly. Anyway, so this approach would help us to make the data more consistent between our tables. As we are talking about the additional tasks, a few words about logging. It's not a bad idea to create for your code to make a logs. So you have an option to troubleshoot something. So you just need to add some logging inside your code. Next one, on lambdas return error 500 status code. Okay, here is we should just handle the all of the possible errors we have while in our lambda function is working. So if it's just DP connection or any kind of unhandled, so I don't know, timeout or something like this, this all should be handled. From the Python point of view, it's just try accept. So you just try to do something and accept something happened. Then now we should just take all of these errors which we would get and just do something. So log it somewhere or just notify someone somewhere. So that would be enough. And the last one, actually it's the first one, but okay, since we're going to from the last one, we should just validate the data. So whenever we're using the post method, whenever we are trying to create the item for in our function, it should validate the data and make sure that, okay, inside the price we have exactly some kind of integer or something like this. So it's not just a text. And if it's the validation process is not passed, so we should return the error 500, and actually that would be enough. So just not to store any inappropriate data inside in our tables. So just to avoid it, because the customers is, I think, the most cruel persons alongside your application, and they would do and they would try anything but you can or can't imagine. Where is the review about this one? 4.4, it's about committing. This one about creating the product. Actually, I think that's it. So maybe one more small hint from my end. So it's about the structure, but actually it's not changed at all from the last time. So I just created one more file in which I created the Lambda function. The code is stored alongside with the previous codes for the previous Lambda functions, and all of the Lambda functions just added to the main file, which is ran by my app whenever I try to CDK deploy. And yeah, it's also don't forget to attach the necessary policies to your Lambda functions to make it possible for this Lambda function to read all the data from the DynamoDB table. I think that's it from my end. I'd like also to call Pavel. Okay, let me use this one. Okay, I'll give the stage to the Pavel, so he also has something to add about in our process. Pavel, floor is yours.
Yes, hello everyone. Well, I think Anton has explained everything about this task, and it's pretty clear, even if it's on Python for those who use JavaScript or Node.js on the task 4. So I probably won't go deep in it. We have some questions I just answered about why do we use. I'm sorry, I read it in Russian, but this should be pretty clear that post and put and what's the differences between those methods in all your queries. What I wanted to say, just as a closure to this task 3, I just want to remind you to more oftenly check the announcements in our Discord chat, because we have 2 wonderful events coming up. The one is, if this is for those who haven't seen it yet, the next one is on 27th of June. It will be a workshop about Copilot, and this is very important that you register via the VR community website, and also fill up at the same time the Google form with your email and everything, with all the data which is required. So you will have a free access for this during this workshop, and you can use all the services which will be provided on the workshop as well. And the second workshop will come on 2nd of July. So these are like administrative things. You can check announcements and events. The second workshop is AWS Immersion Day about async messaging. I think it will be about SQS, SNS services for AWS. The same procedure is here. You register on VR community for this workshop and you fill up the Google form. So everything is set here in announcements and in events. So to be notified, you just simply press interested, so you will be included. I think this is pretty clear, and If you have further questions, we can give it a few moments online.
Yep. Don't thank you, Paul. Yeah, don't hesitate to ask any questions, or as Paul said, you always can go to the Discord channel and ask whatever you want if you have any concerns, questions, etc.
I think there are no questions. No questions.
Looks like. Okay. Cool. So, if you have any, if you would got any, feel free to go and ask in the Discord chat. And for today, actually, that's it. Next week, I would try to make a lecture a bit earlier. Sorry, I'm just tight in time, so this is why I have to make it on Friday. But anyway, thank you for your patience. Thank you for your attention, and have a good weekend. Have a good rest of the day, and bye. See you.
Bye.